Hello everybody. Today we are going to discuss a AWS project in which we will deploy a machine learning model using SageMaker. And here we can also make the end users use this model via a customer application side using API gateway, by which we will create a AWS Lambda function in which we will trigger the SageMaker endpoint, and we invoke the endpoint with the given input values from the customer application side through the API gateway. Here, normally the customer application will send a post request via a REST API through the API gateway, and here the Lambda function will process the input and serialize it, and whatever the input is there, it will send to the endpoint of the machine learning model which we have built on Amazon SageMaker, and the output is sent back to the Lambda function. And we have created an Amazon SNS so that the output, whatever result we'll get the output returned to the customer side through the gateway. Also, we'll send it by email through the Amazon SNS service. This is the overall structure of our model, and we have also implemented a CloudWatch alarm to create a particular alarm so that we need to track whether the SNS is sending a proper email, like within a time duration. For example, a threshold of greater than or equal to 1 messages per second per 10 seconds. And as you can see here, this is Amazon SageMaker in which we have created an instance AWS project, which the instance size is medium. And I have done this using an Jupyter Notebook, Jupyter Lab 1, Amazon Linux 2 version. And if you open the Jupyter Notebook file, here we are using Boto 3, which is an SDK for Python, in which we will use the AWS resources. Here we have declared an object, my AWS project bucket. As you can see here, my AWS project bucket has been created. Now we will import the required Y-Finance data set. And we are taking the data as from 2022 to 2023, which consists of 256 rows, 251 rows in particular. Here, this is the overview of the data set, which consists of price ticker, date, adjacent close, high, low, open, and volume. This is a stock finance data set. So what we are going to do is to predict the opening value of the stock based on the previous data of the stock. So as you know that if you can see here in the zero price ticker, whatever the close value is there, the next day the open value becomes the same. So there is no point in building a model with such data. So what we are going to do is just remove the unrequired columns like adjacent, close, and date, which are not required for the model. Here we have drop adjacent, close, and we have drop date. After that, we have made the data set in a particular way for input manner, so that we will take only close, high, low, open, and volume as our input. And we have declared a target as from price ticker 1 to price ticker 249. That is a close value as targets. As you can see, 117, 174, 179, 174. These are the target values. So we are going to include these targets into a data set. Here we have included our target in a data set. As you can see, here a target is added from previous data. And we have here random sampled the data so that there is some complexity in the model. That's because, as I have just told you before, that there is no point in building a model where you can just get the output from the previous day result, close value. So we're going to randomly sample the data, then train and test the model. Here we have trained the test model with 80:20 ratio, 80% for training and 20% for testing. As we have printed the shape of the training and testing data, we have created a trained CSV path in the S3 bucket. As for example, we have created a bucket name my AWS project bucket VIT. In that, we have created an XGBoost as built-in algo folder. In further, which have created a train folder, in which another we have created a train.csv file, empty train.csv file in particular. Similarly, we have created the same for test path. As you can see, we are printing the path. As we can see, the path is in particularly S3 bucket, my AWS project VIT, in the followed folders. And now whatever test and train data we have previously stored, we are going to push it into the CSV files. Later on, we will import the SageMaker, whatever libraries we need for this model. Like image URS, session and training input. Now we are going to use XGBoost container. Like XGBoost is an inbuilt algo which helps us to give a particular more containers and many algorithms built-in functions which helps us to train the model and save the model, and we can just load the model from a particular container. And this we have declared XGBoost container image ers dot retrieve. This is a particular syntax to declare the XGBoost container. And these are the hyperparameters like max depth, eta, gamma, min child, subsample, and objective. These are the particular hyperparameters for the tree. For the tree we are building in the XGBoost algorithm. And we have created an output path in the same S3 whatever bucket we have created, bucket name, that is my AWS project. As you can see, the output path is also available in the my AWS project path. And the estimator function is declared by using the Sagemaker.estimator and the following hyperparameters are included. And we have kept true for use pod instances, which helps to minimize the zip utilization. And we have made the training and data into content type into CSV format. Now we have, for the model, we have take the train input from the S3 CSV file, which is present in the S3. Similarly, we have given the test input path as whatever the CSV file is there in the S3 test path. Now we are building the model. Like we are fitting the training and testing data into the model. As you can see, the trainable training seconds is 129 seconds, and the billable seconds is 147, and the managed spot training savings are 63.6%. And here we are using CSV serializer to serialize the input data into the required format for the model. So as you can see, the data input can be in a UTF-8 format, like JSON format, like a PDF format, like it can be any type of format. So CSV serializer makes us help to format the input into whatever model input format the model requires. Here the particular predictor we have given the instance type of large. You can choose your particular size for your requirement. And this is the main thing, XGB predictor.endpoint name. You have the endpoint name for XGB predictor. As you can see, this is the endpoint name. Later on, we will use this to invoke this model because we have successfully trained the model. And we have initialized the CSV serializer. So by using this endpoint, we can invoke this model and use it whenever we want. For testing, we have took a particular row of data from 4th of Jan to 4th of 5th. Between only one row is there. So we are going to remove this date and adjacent close and train with this close, high, low, open, and volume input as input. As you can see, first we need to drop the unrequired columns, and the required input are these close, high, low, open, and volume. And now we are going to input this into the ypredict function, and we are going to print the output. As you can see, we have achieved a result, output of 132.69, which is our class string. Now we are going to take an input of unknown format of, like example, UTF-8 format we are going to take, and we are going to serialize the input, and we are going to output whatever the serialized input we have got. As you can see, this format is converted into a proper float type data type. Now we are going to input these values into the prediction function, and the result is printed. This is the same input as the previous input. As you can see, we are achieving the same output. That means the prediction function is giving accurately. We can also give a multiple input as an array, and we are going to run a for loop for each input in the input array. For now, I'm going to test it only with the 0th index in input. As you can see, serialization input called join map string input of 0. This implies the 0th index of input. Now we are going to serialize this input into required format, and we are going to input this into y prediction function. As you can see, we have the same result. And the entire machine learning code, whatever here it is, I'm going to input the same code because I'm going to check the code testability, like if it is giving a different answer or it is accurately giving same answer for the same input. We can use it for different input outputs also, but I'm going to test this with the same outputs in this project. And this is a lambda function code which you can which we later on use in the lambda function. So what we are doing is here we are invoking the endpoint name, whatever we have XGB boost predict function which we have recently printed, right? As you can see, XGB predictor endpoint. This is the same thing what we have used here, and we are gonna declare the endpoint, and for the data inputs in the data, and we are gonna declare empty array for each input in the inputs. So we are gonna iterate over each input, and then we're gonna serialize it, and we're gonna invoke the endpoint, and we are gonna input those values from the input data, and whatever the output is there, we'll append it to the result array, and we'll return the result. Here I'm calling the function. As you can see, I'm here created an array of size 3, 0, 1, 2 indexed. I'm gonna call the lambda of handler function here with these inputs. The result is printed because the same input we are getting the output as same. And here what I have done is that the end users can interact with this model using an API gateway. API on the endpoint is particularly API endpoint. This is not just random. I just made a API gateway for this particular XGBoost model, and this is the invoke URL which I have just pasted in my Jupyter notebook. And the input whatever the user wants to give, and the user whatever he wants to give, he can give this by via the API endpoint, and he can request the output, and the whatever the result is there, it will be saved in the JSON format. And as you can see, we can print the JSON format input output here. Status code 200, so success response, and the output whatever, because same input we are going to get the same output. And this is just how end users like invoke the inputs and get outputs. So we are going to see what is going on the background. So we have created a my stock function lambda my stock function in lambda. As you can see, this is the same lambda code which I have used before, but what we have added here is SNS service. Using Boto3, I have created an instance for SNS. And later on, as you can see, input data and empty result folder to append the data of output. For each input, we are going to iterate and serialize the input and invoke the endpoint. And here, before we have just appended the result to the result array. Now, what we are going to do is we will create a response through SNS via email. What we are going to send is to this topic ARN is the particular SNS instance topic we have created. I'll show you wait a minute. This is the Amazon SNS my stock topic which I have created. For this, I have created a subscription for my particular mail. This is my mail which I have added. So what I will be doing is that whenever I'll test it with this test case assume. This is my test case of same input. As I've said, I'll going to do the project with the same input for all cases. I'm going to test it. Execution successfully. I'm going to go check my mail. I've just got my output. Prediction is this 132.169.39. The same output for because we're using the test case as same input. As you can see in the previous folder, I have seen the same input and we have achieved the same output. This output is sent via the API gateway directly through the API gateway to the client side. So another way what you are doing is through the SNS, we are sending an event to the user. Okay. And here the what is happening? The Lambda function is using SNS service as well as the Sagemaker folder. So we are going to give full access for the Lambda function through a IAM rules. If you go to the IAM, we can find our particular Lambda function. As you can see, my stock function Lambda service, in which I have given the full Sagemaker full access and Amazon SNS full access. So the Lambda code can successfully access my Sagemaker endpoint as well as the SNS service which I'm using here, and the end side user can communicate with the Lambda function through the API gateway which I have declared here. As you can see, the API gateway. This is the same thing as given in the API endpoint. This is the same thing. So via this, as I just previously told you, the customer will send a post request of the input via REST API through the API gateway, which will be received by Lambda, and the input format is serialized, and the input whatever is there, it is invoked into the endpoint and the inference is received by Lambda. And whatever the input the Lambda is receiving is it is sent through the API gateway. As you can see, the response is sent here, and also through whatever we have given, that is the Amazon SNS topic we have created, and we have created a subscription of particular email. The client side, the result will be gone to the user via email. And this is the whole project. And we are doing one more service. We are using one more service called as CloudWatch, which will monitor whether the Amazon SNS is sending an email or not. And I have checked this. As you can see, I have created a CloudWatch alarm. That is a notification code in which I have kept a threshold of greater than or equal to 1. That means for any message published greater than or equal to 1, I'm going to receive an alarm. Just previously, I have input a value and got the output via mail to me. So obviously, the threshold has been reached because number of messages published equal to 1, right? So the threshold limit is greater than or equal to 1. So threshold limit is reached. So as you can see, I have received an alarm. You are receiving this email because your Amazon CloudWatch alarm notification in the ACS server has entered the alarm state. As you can see, this CloudWatch alarm is perfectly watching over the SNS service properly. As you can see, I have just made it into so that it monitors the SNS service properly. As you can see, we have implemented a SageMaker and we have built a model. And this model endpoint is invoked in the Lambda function. And whatever the customer wants, he'll input the format into a post request via REST API through the API gateway, and the output is processed here through the to the endpoint of the SageMaker model, and the output is sent via gateway, also via email, and the SNS here is monitored by CloudWatch. This is the overview of our project of building a model on cloud. Thank you.